Thanks for having me, CrikeyCon. This is my first con talk, so go easy on me. My name is Josh. I'm from a company called TSS, and we're hiring at the moment, so come and see me if you're interested. And this talk is a technical talk. It's pretty technical, and if you're not into the sort of nitty-gritty technical details, you might find this a little bit boring. When I was practicing with my wife, she fell asleep after 10 minutes, but I assume that the audience here is a bit more into the topic. So hopefully you'll find it interesting, because this stuff, I mean, it really gets me. So the plan was just to talk about some vulnerabilities that I found last year, and I was going to talk about a novel remote code execution bug I found in MySQL, but unfortunately, while I was preparing for the talk, I sort of found another vector for the same issue, and they need to patch it, so can't talk about that one. But as a consolation prize, I'm going to talk about this cool SQL injection thing that I found in Node MySQL. So hopefully it'll be interesting. Okay, and I'm also going to talk about some universal XSS that I found in Microsoft Edge last year. So to understand this universal XSS thing, we first have to talk about, we have to understand the single origin policy. And I want to have a disclaimer here. The stuff I'm going to talk about, I'm going to say a lot of things as if they're the whole truth, like as if I'm giving you the whole information, but I'm really just giving you enough information to go from one step to the next. Because if I try and explain all the details of sort of the topics that we're going to cover here, it just won't work. So just understand that when I say something, I'm not telling you the whole truth. I do plan on writing some blog posts in the not too distant future that might have some more information in it. So if you want to follow me at JPG Inc., but with a 1 instead of an I, on Twitter, I'll post some stuff there when I'm ready. And I really like live demos, so I think that the best way to demo this stuff, to explain this stuff, is to show it to you. So I've got here a very simple page. It's got an iframe in it. An iframe is it's basically just a website that goes inside of another website. And cross-site scripting, the scripting part, that's talking about JavaScript, right? So I'm going to try and explain the single origin policy by using JavaScript to play with this iframe in the page. Okay. Now, when I was attending talks, I noticed that you can't really see the bottom of the screen very well. So can people see this here when I'm typing? Yep. Yep, it's big enough. Very good. Okay. So the first thing you've got to do if you want to play around with a iframe with JavaScript is you've got to get a handle on it. Now, when I'm talking, don't look at me, look at the thing, and you're supposed to be looking in this console window here. That's where all the action is going to happen. So what I've done just now, I've got a variable x now, and x has a handle on that iframe. So now we've got a handle using JavaScript. Well, I mean, normally with an iframe, you want to load a web page in it. And you do that by just giving it a URL. And it's a bit squished here, but you can see that the iframe now has a web page loaded into it. Now I've loaded the web page localhost, and this top web page here, that's also localhost. So at the moment, inside the iframe, I've got a website that's on the same domain. That'll be important later. Okay. So now I've got a web page loaded in. What can I do with my JavaScript handle? What can I do with JavaScript? Well, I can reach into that iframe, and I can read the contents of that iframe. So I've done an alert of the inner text of that iframe, and you can see here you've got all the text pop up in that alert box. Another thing I can do is I can reach into the iframe and I can change the contents of it. So here I've just set the inner HTML to say hello world, and you can see the iframe now says hello world. It's pretty simple. So the next thing I'm going to do, and I just realized it's not going to work because I don't have internet. Well, it'll still work, but I'm going to try and load CrikeyCon.com into this window, and it's going to 404 or whatever because I don't have internet. But let's just pretend CrikeyCon's loaded in there, and I'm going to try the same two things. I'm going to try and reach into this 404 page and read the contents of it, and then I'm going to try and change the contents of the 404 page. And if you've been paying attention to the console, you'll see these permission denied errors. So that is basically the single origin policy. So what we've got here, we've got the main page. It's sitting in localhost domain. And then we've got the iframe, and that's sitting in the CrikeyCon domain. And how it works is when JavaScript from one domain tries to act on a page in another domain, the browser steps in and says, hold on a second, I'm not going to give permission for this, I'm going to block that. So just to be clear, it should be impossible for JavaScript from one domain to affect a website on another domain. That's the single origin policy. Okay, easy, don't even worry. So one day in the group chat, one of my colleagues, he asked if anyone knew how to solve this little challenge here. He was working on a client website, and he had this, this XSS injection point if he can get inside this if statement here. So I started having a look around the internet, and I stumbled upon the JavaScript open function. And this function's just become the focus of my life pretty much ever since. And if you recall, when we were talking about iframes, I showed you that it was possible for the main page to get a handle on the iframe that's sitting inside of it. I didn't demo it, but the iframe is also able to get a handle on the parent page. And if you look into it, there's some valid reasons for that to happen. Now, that's sort of obvious. And what wasn't so obvious to me at the time was that pop-up windows, you know, when you open up, click a link and it opens up in a pop-up window, these things get a similar relationship. So let's say you've got a window here, and you use this open JavaScript function. That opens up a pop-up window. That's what the function does. And the browser, it sets a link from the pop-up window back to its opener window. And it puts that link in a JavaScript variable called opener. If we have a look back at this challenge, you can see here we've got this opener variable inside the if statement. So if I say this if statement in just plain English, it's saying if this page is a pop-up window. And if it is a pop-up window, we get inside here and we get our XSS, and we've won. So the solution to this challenge was to open up the vulnerable page in a pop-up window. So I went back to my colleague and I said, you know, this is how you solve it, and he was happy, and I went back to my own work. A little bit later, he came back with this slightly different challenge from the same website. And it's a little bit more complicated because to get inside this if statement, we have to bypass single origin policy, or at least we have to trick it. And I think the best way to demo this is, again, with a live demo. So I'm going to use that open function to open up a pop-up. And you can see it here. And let's see if we can stack this stuff. OK. Everyone can see this one as well, I assume. OK. So I told you that this pop-up window should have a variable called opener in it. And I'm just doing an alert opener, and the alert box says that there's an object there, and you can trust me that it's a link back to this other page. I also told you that there should be a relationship between these pop-up windows that's similar to that of an iframe. So what could we do with an iframe? Well, we could reach back into the iframe and read the contents of that iframe. So I'm going to grab the openers, this window's contents, and you see it says this has an iframe in it, and the alert box says this has an iframe in it. Another thing that we could do is we could reach into the iframe and change the contents. So I'm going to do the same thing. I'm going to change the inner HTML of this page, and it's going to say hello world, and that works. So let's go back to this little challenge here and have a look through this if statement. So we've got if opener, and that just says, you know, if I have a window that's opened me as a pop-up. So if the window that opened me has a location, and the location is just the URL, and if that URL includes the word Crikey in it, then we've won. OK, and let's just demo that. I'm going to alert my opener's location element, and if you can read that alert box, it says crikey.html. So we've won. We got inside that if statement. Great, easy. But actually, it's not that simple, is it? And let's draw this out. I'll show you what's going on here. So let's say up here, we've got our page that has XSS in it, and it's very sad. And what we've done so far, we've had one window, and we've opened up this pop-up window, and that window has a link back to its opener. And in the URL of this guy, we've got Crikey, and that's what we need. And so far, I've demoed that we can go from this window and we can reach back here, we can read the URL, and I've shown it in an alert box. But what's this page? This page is nothing. It's just some random page that I opened up. If we want to actually exploit this XSS here, we need to open up that page in a pop-up window. And then this page has to be able to reach back and read the Crikey out of the URL. So let's try that. And we'll pretend that crikeycon.com is a vulnerable page, but we can't because I've got no internet, but it's still going to work. And then I'm going to go back, reach back to my opener, and I'm going to try and alert the location, and we get that same permission denied error that we had with the iframes. And why is this? It's the single origin policy. So we've got the window here, it's sitting in crikeycon.com domain, and JavaScript from that window is trying to act on this other window here that's in localhost, and the browser's just, it's not going to allow it. So single origin policy says no, so we can't do it. But there's some interesting stuff that you may have noticed, probably not, because it's only interesting to me. So we had this pop-up window, we opened up some random window, and then what I did just now is I moved that window to crikeycon.com, destroying this window. That's all gone now, doesn't exist anymore. But this link back to my opener, it was still defined on this new window. I found that to be a bit weird. Now, the single origin policy, if I try and do anything with this link, it gets blocked by the browser, because we shouldn't be able to do that. But the only reason we can't do it is because it's in a different domain. So check out this little trick. I'm going to move the opener to crikeycon.com. I'm going to try the same thing. It might not work because they're 4.0 forward. Oh, it does. Look at that. So because these two pages are both in the 4.04 domain, they're allowed to communicate with each other. I found that really fascinating. So we've now moved this guy over to crikeycon.com, or the 4.04 domain. So this guy's gone, the original opener, and the pop-up's gone, but this link between the two pages, it's permanent. And I just got, like, I don't know, for some reason, this permanent link between openers, it really interested me. And it does solve this XSS problem here. It's a little bit more complicated, and it starts to get confusing, so I won't go through it. But I announced to my colleagues when I found out about this link, I'm like, there's definitely universal XSS in here. There's some way that we can exploit this for sure. And they all laughed at me, and who's laughing now? So I started just playing around in the JavaScript console, like I've been demoing here. Just playing in the JavaScript console, doing all these weird things. And remember to buy, what we're trying to do with Universal XSS is have this link to a different domain and still do stuff, when the browser should be saying, no, you can't do that. So I'm trying all this different stuff, and no matter what I did, the browsers, they're pretty smart. They enforce the single origin policy. But I learned a lot of stuff along the way, a lot of really weird things that browsers do, not necessarily vulnerabilities, but just interesting behavior. And one of the things I noticed was there's some funny behavior that happens with the alert boxes. And let's keep demoing. So what I'm going to do now, I'm going to start 2 timers, one in each of these windows. And hopefully you can see that there's numbers that are printing out on both of these consoles. It's just counting up 1 second, and it adds another number to the console. Now watch what happens when I do an alert box on one of these windows. You can see the one on the left, I don't know if it's your left, but whatever. One of them is still counting, it's 25, 26. But this one over here, it stopped. So the JavaScript in this page is frozen. So what we've learned here is that the alert box, that's a blocking function, that pauses JavaScript execution in the window, basically. It's not a vulnerability, there's nothing wrong with that. It's just a little bit interesting. When you click OK, it's like hitting unpause, and JavaScript just continues from where it went off. So what do you think is going to happen to the numbers that are printing out here if I go from the pop-up window, and I go from the pop-up window and I use JavaScript to ask the one that opened it to do an alert box? Which of the windows, like what's going to happen to the numbers? Is it the original window that's going to stop because it did the alert, or is it the window that has the alert box on it? Does anyone want to have a guess? Original? Wrong. Get out. No, you can stay. You can stay. I'll just show you. It's both of them. So this one stopped here, and this one stopped here. And, I'm looking at this behavior. It's a bit interesting. Not a vulnerability or anything. And I'm like, what's the next logical step? So we've got two windows here. Both of them are frozen. There's no JavaScript running. And I was like, well, what happens if we open up another window? And we have a third window. So we've got two blocked windows, but if we open up a third window, that'll be unblocked. And then what happens if I use this third window to reach into one of the windows that are blocked? I mean, what's going to happen there? So let's try it. I mean, it's just logical, right? Don't even worry. So let's see if we can do this here. Okay, so I've got numbers printing on each of these pages now. I'm going to alert on my opener so that I stop the opener and I stop this third pop-up. So now we've got two frozen, but this third one is still running. And then if I do an alert on this other one here, I mean, it shows up the alert even though that page is already frozen. So now we've got like a double frozen page. So, this is starting to really interest me here. And so we're getting into all these sort of really weird edge cases. Now remember, our goal here is to navigate one of these tabs to another domain and then continue to execute JavaScript. So I started playing around with these alert box, sort of the blocking behavior here, and I'm like trying to navigate stuff around. I'm doing while loops and all this sort of nonsense. And then I see this happen on one of my attempts. And what we got here, ASDF.com is just the easiest website to type because you just go ASDF and then .com. So I use that all the time when I'm playing around. And if you've ever visited ASDF.com, there's no alert boxes. They don't have any JavaScript alert boxes pop up. But here we've got this alert box here that says ASDF.com needs some info from you. It's actually a prompt box, but it's the same as an alert. And in the background, I'm not sure if you can see, but it's in ASDF.com there. And that should not be happening. Now at this point, I've got two theories here, because I'm doing some really weird stuff. I think by now I've got 5 pop-up windows happening, and I don't know what I'm doing. But I think 2 things could be happening. One, there's just a GUI issue. Like, it's just got a bit confused, and my domain has done an alert box, but then ASDF.com has loaded behind that alert box. So we've just got like it's still a little bit of an issue, but it's not a biggie. The other option is that for some reason, ASDF.com is executing my alert box. And there's a distinction there which is very important. So if we recall back to the first demo, the iframes or the pop-up windows, one of the things we were allowed to do with the same domain is change the contents of the website, right? But that should be impossible from another domain. So I changed the code a little bit, and instead of doing an alert box, I changed the contents of the site. And then I got this. We're on ASDF.com, and I changed ASDF to say hacked by JPG Inc. So I'm like, yes, yeah, we got this. Yes, it's full-blown universal XSS. I was so excited. I'm like, let's report this to Microsoft. You know, that's the next step. But I had a bit of a problem. I could only get this thing to work once every, like, 20 or 30 times I ran it. So, I'd sit there and I'd refresh and do its thing, and then it didn't work, so I'd close everything and refresh it and do its thing, and then eventually it would work. And I just want to show you using Paint sort of where I got to. So at this point, I'd gotten rid of all 5. Well, actually, I think I had 5, but I managed to get it down to just 3 windows. So I'd load this window first, and this window would open the 2 pop-ups, and both of them would get a link back to the original one. And the only other thing this window did while it was loading was give these guys a handle on each other, so that everyone could talk to each other, everyone was happy. And then he finished loading, and he was done, sort of. Then this second window here, it would wait until this window either existed or finished loading, I can't remember. And then it would go to its opener and ask its opener to set a timer to run as soon as possible. And this timer here would go to this window, and it would do a while loop that would last for 5 seconds, just to keep that window busy, sort of like a blocking thing, like the alert box. And then immediately after setting this timer, but before the timer ran, this window would ask that window to do an alert box. Remember, they block 2 windows, so I don't know what's going to happen here. But then that's all that window did, so it's not too confusing until we get to the third window, and it sets 2 timers, and this first timer goes off after 3 seconds. Now, whether that 3 seconds happens before the end of this while loop, I'm not sure, but after that 3 seconds, the timer goes into this window, and it does a loop for 10 seconds, so it keeps that window busy. And then the second timer happens after 4 seconds. Well, it goes to this guy, and it moves it to ASDF.com, and then immediately does an alert box, and then another alert box, and then another alert box, and then comes back to itself and does an infinite loop. So basically, my problem is here, I have no idea what's causing this issue. I got no clue. So what do you do? What do you do? Don't even worry. AutoHotkey. It's the best. It's my best friend in the world. I love AutoHotkey. It's like a scripting language for Windows. Basically, it's made for sending clicks and key presses or creating hotkeys, but I use it for everything. So what I did was I wrote a script, and all it would do would click the alert boxes at certain times, and it would sort of wait to see if it hits this issue. And if it hits the issue, it stops and lets you marvel at the universal XSS. And if it doesn't, it closes closes Edge, killing the process because I did all sorts of crazy things. And sometimes it didn't close. And then restart it. And I got it to the point where it would run. I'd get pretty reliably the XSS, universal XSS to fire once every about 500 times it ran. So I'm like, that's great, good enough. I zipped it all together, I sent it to Microsoft, and they were like, I don't know what this is, and they sent it back. So I went back to the drawing board. And what I did then, so I had this script, and I knew that if I waited a couple of hours for it to run 500 times, it would tell me if the thing's working. So I started taking away a line of code at a time. So I'd be like, well, I've got 3 alert boxes here, maybe I can get rid of 1. Maybe that one's not needed. And then I span up 5 or 6 VMs, and I ran them all in parallel and waited for one of them to hit. And if it did, I'd get rid of another one. So eventually, I got rid of all the alert boxes. So had nothing to do with that blocking thing that we were talking about. Got rid of these stupid while loops. They didn't do anything. Eventually, I was able to get rid of one of the pop-ups. So you only needed 2 windows. We were getting somewhere. And I got to this little, oh no, that's going to crash it. Oh boy. Oh boy. Hit OK. You're right. Don't worry. Okay. So I got to this, much more elegant solution here. And it's just two windows, and you set that target here. I was going to do crikeycon.com, but I got no internet. You hit start, and then sometimes, not every time, you get this hacked by JPG Inc. thing. So I'll just show you what we've got to so far. So we've got a page here, and we open up the pop-up. We've got this other page. And this guy here, all he does is he toggles between my domain and the target domain. So this is the target, and this is me. That's all he does. He just toggles between those two domains infinitely. And then on this guy, I've got an infinite loop. And what it does is it sends a chunk of JavaScript. And you can send a chunk of JavaScript using the eval function in JavaScript. So it sends a chunk of JavaScript to this window. And what that JavaScript does is it checks, am I in my own domain? And if I am, just do nothing, because we don't care about that. Remember, we're trying to violate the single origin policy. So if I'm in my own domain, I don't care. But if I'm in this other domain, or any domain that's not me, change the contents of this website to say hacked by JPG Inc. And at this point in time, I'm theorizing that what's happening is, every now and then, this JavaScript gets sent to the window and sort of intercepts this in-between part. So I'm thinking that maybe the single origin policy check happens first, and then the message starts sending, but pauses, because we've probably got two threads going here. So it pauses this thread while the JavaScript is like halfway through sending or something. Then it moves to this new domain. So when the JavaScript eventually hits this target window, it's in a new domain, and it just executes as if it's come from that domain. So that's my theory at the moment. It ends up being correct. But I send that proof of concept to Microsoft, and it's a shame that it worked this time, because apparently usually it doesn't work. So they sent it back saying, no, that doesn't work. And I'm like, how the hell can I make this better? And this is where we sort of tie everything we've learned today together. Iframes. I mean, that's the way to do it, right? So instead of toggling this whole window here between two domains, I just put a whole heap of iframes in there, and I started toggling those iframes to different domains. And that worked, and I'll show you. I think it's pretty cool. So now, instead of just the one page, I've got like 50 iframes in there, and you can set your target, and then you can come back here and you can start seeing all of these things toggle between, and you can see on my second attempt it works, 9th attempt, it's a lot better. And I sent this one to Microsoft, and they're like, yeah, no problem. And they fixed it earlier this year. So, does that make sense? Everybody follow that? Anybody confused? Yeah, that's because it didn't happen yet. I did get a bounty from Microsoft. They were very, very kind. That was nice. Okay, so that's the end. That's Universal XSS 101. Not too difficult. Don't even worry. How much time do I have left? Good. All right, that should be enough. So hopefully this second bug's a little bit less confusing. And it's something that I found sort of like on the way to that remote code execution bug, so I thought it was rather relevant. So let's set the scene. Say you're doing a web application pen test, and you've got like a user section. You've got to log on to that application, and you see the logons function. It's taking a JSON blob. So hopefully you know what a JSON blob is, but if you don't, I'll give you a quick course. So the server sees these two squiggly line things, the curly braces, and when it sees that, it knows that inside it's got key value pairs. And here the key is username, and the value of username is Josh. And the key is password and the value of password is secret. Now I've highlighted secret here because I want to point out that the type of secret is a string. It's a string type. And when you're doing a web app pen test, you're just trying to break the application in unexpected ways. So you might be like, well, what happens if we send it another JSON object where it's expecting a string? You know, what's going to happen? So you just send it, and then you get your first clue. You get an error message. It says unknown column in where clause. Now, anybody who has done like SQL injection or is a web app pen tester, they probably recognize this as, maybe this is some sort of SQL injection bug. And it's a bit interesting because this thing here, if we look back here, we sent at the server, so we know that we're breaking it and not some other weird thing. Okay, well, what do you do next? You've got an error message. Well, ideally, you have the source code for the application, and you can just look through the source code, try and find where the error is happening and get some more information that way. But even if you don't have source code, if you're doing a black box test, you can Google the error message. And when you're using your Google skills, you want to try and get as much information about the back-end infrastructure or the application libraries that are in use and stuff like that. And you can already see here in just that error message, you've got the X powered by Express header, and you can trust me that that probably means that Node.js is being used in the background, so you can use that to help you Google stuff. And if everything else fails, just put SQL map against it. So anyway, I happen to have source code, and I tracked the issue down to a couple of lines that are a bit like this. So the first line there's SQL query. Basically gets everything from the user database as long as you send the correct username and password. At least that's what it's supposed to do. And these question marks here, they have a special meaning, which we'll get to in a second. Two other things I know from the source code is that Node's MySQL library is in use, and SQL string is the library that's used for string interpolation, which is these question mark things, which we'll get to in a bit. So we don't really understand what's going on yet. I mean, I've got the line of code that's erroring out, but I don't know why it's erroring out. So next thing we want to do is probably check the documentation, and you can go to the MySQL thing is open source, so you can check out the code on GitHub. And pro tip, look for security tags in the issues, because often there's security issues that are just not fixed. So let's, since I love live demos, let's do some research together. So here's one I prepared earlier. So you Google MySQL node library, and this is the NPM. It's anyway, you'll find this if you just Google it. And this is all the documentation. You start having a look through here, but it doesn't really tell you what's going wrong with the application. So you might go to the GitHub. And before you start looking through all the boring code, you go to your issues and you search for security in the tag in the open issues. And you find this thing from, reported in 2014, some security issue. So you're like, oh, well, let's have a look at that security issue. And you go up here and you've got this guy, the Cure, and he's got this error message. He's done some vulnerability scanner thing, unknown column, whatever, in where clause. And you're like, oh yeah, that's the same error that I'm getting. So, we're on the right track. So you read through this thing and you keep going, and then you get to the bottom and you got this guy Skeggs. And Skeggs is like, don't worry, I've had a look at the code. There's no way that you could get an injection vulnerability. All you get is a syntax error. Don't even worry about it. But even so, you don't know why you're getting the error, and you're interested to, you've got this obsession about knowing everything. So you just keep digging, right? And some of the stuff you read in here, you start to understand that the issue that is with this SQL string interpolation library. So you go to their documentation and you're like, well, I'm just going to play around with this on the console. So what I've done here is I've just copy and pasted the basically hello world thing for SQL string. And See how big we can make it. So what we got here, we've got this select everything from the users table where the ID equals question mark. Now, it's not exactly the thing that we had in source code, but it's pretty similar. And what you've got on this line safely formats this query by replacing this question mark with the value in ID, which here is 1. This is just the hello world SQL strings. And it's node, remember that thing? So we can just run that, and you see here that ID equals 1, and that's sort of what we expected. So another thing we can, ours was we sent secret to it. That was what we did first. So let's see what happens there. And you can see that it replaces it with secret, so that's what we expect. And just to check, we can try your old or 1 equals 1, just your regular SQL injection. And if you don't know SQL injection, you can just trust me in this backslash before the single quote. That's the correct way to deal with SQL injection attacks in this case. So I know the library is pretty good. But what we were doing, we were sending and then I can't remember what we were sending after, but we want to see what this does. So we run it, and we get this weird stuff happening now. So before we were getting ID equals the value. But now we're getting ID equals ASDF. And I don't really know, or I didn't at the time, what the hell that's going to do. So, of course, we'll just open up the MySQL command line, because we can just play around with it, right? And let's see if we can do this. Can people see the bottom? How do I make the bottom? Well, too bad. You're going to have to deal with it. So anyway, we can just paste this into MySQL, and I need to use some test database that I've set up before. We paste this in, and it says here, unknown column in where clause. So we know we're on the right track. We're still going. Just bear with me. You've got to keep going. So let's try and understand, because we want to understand everything. You see there's these, I don't know if you can tell in the back there, but these are single quotes, but this is backticks here. And I didn't know what that was, so I had to do a bit of Googling, and I found out that backticks in MySQL indicate that either a table name is there or it's a column name. So what I'm doing, I'll just go back up here. So I've put backticks around this. I'll read out this. We've got select everything from the users table where the ID column, where the value in the ID column equals the value in the column equals the string ASDF. And it's saying unknown column which makes sense because there is no column in that database. So if the only reason we're getting this error is because it doesn't know what column it is, what happens if we give it a column that exists? Well, we don't get the error anymore. So that's a step forward. So what we've got now is where the value in the ID column equals the value in the ID column, which is always going to be true, right? Equals ASDF. So what if we change this a little bit, and instead of ASDF, we write true? Well, it still didn't select everything, so we haven't won yet. And why hasn't it selected everything? All right, well, let's try selecting true. So what's that? Well, true, apparently, in MySQL is 1. That makes sense. And if we select false, false is 0 here. So that sort of makes sense. So what happens if we select A equals A equals A? And I sort of expected this thing here to equal true. Like just in my head, A equals A, that's true, equals A. That's true, right? But it's coming up as false. So what's happening here? Well, let's go one step back and have a look. Select A equals A is true. So what's actually happening here is it's evaluating the first select A equals A, and then that turns into true, which we just discovered is 1, right? So what we've actually got is select 1 equals A, which you see here is false. Obviously, 1 does not equal A. But 1, the number, does equal 1, the string, in MySQL. So if we go all the way back to our problem that we are having, our syntax error that can't possibly lead to injection, and we just put in the value 1, because the ID column always equals the ID column, and that's true, which is 1, the number 1, which equals the string 1, then we can make any where statement equal true. So, what does this mean? Well, it means that I don't need to know the password or even a username to be able to log into this web application that I'm testing. You can bypass any where clause, even if the developer has correctly used a SQL string escaping library. If they don't check the type of the data that comes in, then it's game over. And that's all I got, actually. The takeaways are hopefully you learned something. I don't have any other takeaways. Yeah. Okay, thanks.